Hey everyone, Miss Knoll here. Has a little practice test for you guys. And the test itself, that'll be on Friday, will not be short answer. It'll be multiple choice, and it'll be in the quizzes. So put your mind at ease if you're a little bit freaked out about the amount of work we're going to have here. You will have choices, so you'll know if you're right or wrong. And the first thing in this unit on polynomials that we talked about was factoring. And we factored a lot this semester, even before we went on this break. And when we factor, the first thing you always try to do is get a GCF. And if I look at this expression, x cubed minus 16x, I see there is a GCF of x. So I'm going to undistribute an x. And if I divide an x from x cubed, that's going to leave me with x squared. And if I divide an x from 16x, that's going to leave me with minus 16. And then now we have a little bit more options in terms of ways to factor, but I see this is a quadratic. And when we see quadratics, we try to unfoil them, meaning take that one group and turn it into two. And this one will unfoil into two factors. This is a pretty basic one because the only way to get x squared is having x and x come first. And then to get negative 16, the two numbers that multiply to negative 16 and add to 0 are positive 4 and negative 4. Or another way you could have factored that one is the difference of squares. If you have a perfect square minus a perfect square, that's going to factor into whatever was being squared plus the other thing being squared. And then whatever was being squared first minus what was being squared second. And if you look at my original here, x squared, you see the x matches a. Sorry, this is a square. I have to write with my finger. So that means x and x come here, which we put. And then also 16 is the same thing as 4 squared. So in B's place is where we put the 4. So another way to get the same fully factored answer. Be careful on multiple choice on a question like this. They may give you this as a choice. They may tell you this is the answer as a choice, and this is an answer. Well, this is wrong because it's not fully factored. So make sure on the multiple choice portion, you fully factor it. I'm going to leave two for you. The answers are in this document, so I'm going to post this. And at the bottom, all the answers are here. Oh, I see there's graphing on there. Don't worry about graphing. We already graphed in the last unit. So really, these will be done after question 14. Another way we factored in this unit was by grouping, and we would factor by grouping if you saw 4 terms. So this is about a week and a half ago. So if you see 4 terms, that tells you, well, I'm going to group. 3 terms typically tells you it's a quadratic. So here I'm going to group my first 2 terms, and I group my second 2 terms. And then it's just a bunch of GCF. So from the first 2 terms, I see the GCF in this red set of parentheses is x squared. So I undistribute that. And after I do that and I divide it, I'll be left with x. Right, x cubed, I divide out the x squared, I have x. 3x squared divided by x squared is going to be with a minus 3. And then if I go on to the blue group, the GCF of this blue group is a negative 5. So I undistribute that negative 5, and then when I do that, instead of negative 5x, I'm left with just x. And instead of plus 15, I'm left with minus 3. And then here's the beauty. These 2 groups in black now, the x minus 3s, they match. So that's also a GCF. So I can pull that x minus 3 out in front. So any GCFs I can undistribute. That is a GCF because they're being multiplied. And then once I undistribute it, I'll be left with just with x squared, right? Because I'm pulling that x minus 3 out in front. I pulled this x minus 3 out in front, and I'm left with just minus 5. And then I would check, is that a difference of squares like we talked about in question 1? No, it's not. And I made a couple comments on some of your assignments when I returned them. Negative 5 is not a perfect square, so it doesn't factor this way. Or think of it this way. If you're trying to remember or think of 2 numbers that multiply to negative 5 and add to 0, there aren't any. So that one is completely factored. Not a whole lot of tricks there in your answer choices. 4 is also a grouping. So again, the answers are at the bottom of this document. So you can check them on your own. In 5, we kind of talked about this. Usually, I know I skipped 2, but usually when you see 3 terms, you think of quadratic. And when you see 2 terms, you're thinking of one of the special patterns. So this one was both. When I got the GCF out, it ended up being quadratic and a special pattern. If I scroll down to number 5, I see 2 terms. So I'm thinking special pattern. I would still look for a GCF first, but I don't see any. I can't get a number out of both of those, and that doesn't have any x's. So the special pattern that I think is going to work here is that difference of cubes. So if you remember the difference of cubes pattern, which usually you'd have to memorize, but now you can have your notes open when you take this test. If you have a perfect cube minus a perfect cubed, it will always factor into whatever those things being cubed subtracted. And then a squared plus ab and plus b squared. So if I look at this pattern and I try to match it up to a cubed minus b cubed, I have to think to myself, well, what cubed is 27x cubed? And I have to think to myself, what cubed is 125? And if you need to, you can use your calculator to kind of figure that out if you can't see it right away. But I know 27 is 3 cubed. And obviously, x cubed is x cubed. So this is 3x cubed. And then what cubed is 125? Well, that's a 5. And now the pattern's super easy to use because everywhere there's an a in the pattern, we're going to use 3x. Everywhere there's a b in the pattern, we're going to use 5. Don't have to worry about the signs because the pattern accounts for those signs. So when I go ahead and plug this into the pattern, instead of a minus b, like here it is in the pattern, we're going to have 3x minus 5. And then if I continue on, and this is where a few of you made mistakes, and again, I made some comments. If I do, let me kind of show you this in a different way. I'm going to do my work over here. 3x squared, right? Because that's what's going to go here. 3x squared is 3x times 3x, which means simplified, this becomes 9x squared. And that was a common mistake I think I went over in a second video on factoring. A times b, that means 3x times 5. That's easy enough. That's 15x. And then lastly, b squared is 5 squared. That's 25. I'm sorry about all my colors there. And we'll factor a little bit later on here in this sheet, but for now, if it tells you just to factor, these would be your final answers. I'll box this guy. Oops. Division, in the notes on division, we went over in the Google Meet, we went over 2 types of division, long and synthetic. But I said in my Google Meet on Monday that synthetic tends to be the easiest, but the setup's similar. On synthetic, the inside of your division is the coefficients of the first polynomial. So all these numbers that I'm underlining in red, including their signs. The outside will be whatever's being subtracted, the opposite really of what you see here. So because I see a minus, I'm going to have a positive 2 on the outside. The inside, you keep all the coefficients as they are with the same signs. And then procedurally, these are pretty easy. In synthetic division, we're faking division. I drop the 5. It's always the first step is to drop the first coefficient. And then from here, we're going to multiply what's outside of this L, this big L, and we're going to add what's inside. So 2 times 5 is 10. And then I add negative 12 and 10 is negative 2. 2 times negative 2 is negative 4. And then I add 13 and negative 4 is negative 9. And then I multiply 2 times negative 9 is negative 18. And then I add and I get negative 26. And then 2 times negative 26 is negative 52. Let's see if I made a mistake here somewhere. 5. 13 minus 4 is 9. Oops, this is where I made a mistake. Let me rewind. This happens. How I knew I kind of made a mistake somewhere is these numbers were getting really big, and these problems are all rigged, and so are the ones on your quiz. You shouldn't see any really large or really small numbers. So I don't know if any of you noticed when I was doing it, I made this 9 negative, and it shouldn't be. It should be positive. So let me go back. Now 2 times 9 is positive 18. That's going to give me here a 10 when I add down. 2 times 10 is 20, and when I add negative 25 and 20, I get negative 5. And then remember, when I'm dividing here, I showed you with the long division, even though I'm neglecting to account for all these k's, this k and all of these k's are still there. They're just hiding. And this whole time they're hiding, they're dropping an exponent because every time I'm having k to the 4th divided by k. Well, that means in my answer, that's going to be 5k cubed, right? Because I divided a k. I divide a k from the next term, so it means it's going to be minus 2k squared. And then plus 9k plus 10. And then that meant whatever was left over was my remainder. So here that would be negative 5 over what I've been dividing by this whole time, k minus 2. And then again, you can try 8 on your own. The answer's at the very bottom of this document. I'm going to do one more like we've done in the Google Meet on Monday, and then I'm going to kind of expand upon it in a second video. I only have 15-minute max on these videos. I'm coming up on the end of that. So I'm going to stop after this one, but start a new video. So one of the things we did on Monday was the whole purpose of this division was it gives me a way to factor if grouping doesn't work or if a special pattern doesn't work. So if you look at my problem here, I can't, if I tried to group these, I think I could get some GCFs out, but I won't have that really nice common group GCF like we did up here. If I took GCFs out in number 9, the one I'm about to do, I'm not going to end up with the same black group. I won't have that same set of parentheses. But if I give you a factor, so a factor is given, I'm telling you that x minus 2 is a factor. That means if we do division, like we just did in number 7, I should get a remainder of 0. That's good for us because that means hopefully whatever remains I can factor further on my own. So let's see if that works here. So here's a factor. I'm going to do division. Remember, I should get a remainder of 0. I see x minus 2. That means a positive 2 is going to go on the outside. If that was a plus, a negative 2 would go on the outside. My coefficients go on the inside. I notice I'm missing an x squared, right? There should be an x squared right here, but there's not. So that means in my division, I'm going to use a placeholder of 0. And then negative 27 and 54. And my process is I drop the first coefficient, then from here on out I multiply and add. 2 times 1 is 2, and then I add, I get 0. 2 times 0 is 0. I add, I get 0. 2 times 0 is 0. I add, I get negative 27. And 2 times negative 27 is negative 54. I add and I get another 0, and I'd put a big smiley here because I'm happy. I just proved that's a factor. So this is one of my factors, x minus 2. And I'm also happy because I divided this that started at x to the 4th is now x cubed. This would be 0x squared. That would be 0x, but I have 0, so I don't need them. So I have x cubed minus 27. And then this is not factored completely because x cubed minus 27, that's the same difference of cubes pattern we used up here, that exact same pattern. So instead of a cubed, we have x cubed, and then b cubed is 27, so that's 3 cubed. So when I factor this completely, x minus 2 is the same x minus 2 from beginning. And then using that pattern, I'm going to have x minus 3, right? Because the pattern is a minus b, and then a squared is x squared. A times b gives me 3x. And then last plus b squared is 3 squared for us, is plus 9. So I just used division to factor when it looked like I couldn't factor in the beginning.